Okay, good evening, students. So, we are dealing with the second chapter of class 10 physics, that is work for energy. Okay, so we have reached the end part of this chapter, and that is the energy conservation of energy. So, today we will deal with principle of conservation of energy. Okay, so what is principle of conservation of energy? As we all know that in our universe, the total energy is conserved. Okay, so it states that in our universe, the total energy is constant. Energy neither be created nor be destroyed. Only it can transform from one form to another form. And we have already seen that there are many forms of energy. Okay, so the most important form, that means in our mechanics, in our physics, that means in our in our mechanics, that means we have a very important form of energy, that means mechanical energy. Okay, so mechanical energy is one of the form of energy. Okay, so mechanical energy is there, heat energy is there, sound energy is there, wind energy is there, solar energy is there. So various type of nuclear energy is there, so chemical energy is there, so various forms of energies can be there. Okay, light energy is there, so various forms of energies are there. And in a principle of conservation of energy states that total energy in the universe is constant. Okay, it cannot be created, it cannot be destroyed. Okay, so the only thing you can do is that we can transform one form of energy to another form. Just like I gave the example, that means the fan is moving. We have already discussed these things. That means if the fan is moving, that means at that time the electric energy is transformed to mechanical energy. Okay, or say wind energy. Okay, so in windmill, wind energy is transformed to electric energy. Okay, so in hydroelectric power plant, okay, so the water force is revolving the turbine wheel, and with the rotation of the turbine wheel, the electricity generated. So from the hydroelectric power plant, we can say the mechanical energy of water is transformed to electrical energy. Okay, so there are different, so in every event in universe, if I do some kind of work, then only the energy transfer. Suppose if I suppose if I throw this pen, that means inside my body we have energy, so I am giving the energy to this body, and this body is moving. That means my mechanical energy, that means my energy is transformed on this body, and the body is moving. Okay, so that means the energy is transferred. Okay, so the principle of conservation of energy states that in our universe the total energy is constant. Energy neither be created nor be destroyed. It only can transform from one form of energy to another form. Okay. Now let's take the example that how the energy is conserved. Let's take a real example. Okay, suppose we take a ball, and throw it up. Or I can say I take a ball and just drop it. So drop it from a height. Let's say this is the floor or base. Or this is, let's say, this is the ground. Okay. So from the height h, let's say this is the ball. This ball is at height h. The ball is at height h, and the ball, it has mass m. Okay, so I have just dropped this ball from a height h. Okay, then the ball will go downward due to acceleration due to gravity. With the acceleration due to gravity, the ball will go downward due to the force of gravitation. We all know that from Newton's laws of gravitation, we know that every body on the earth is attracted towards the earth by the force of gravitation. We all know this. So this ball will go downward due to force of gravity. That means the ball will go downward due to gravity, mg. This is the force acting on the ball. Let's say this is the position A. Okay, so the ball will go downward and it will ultimately it will reach to the ground. Just I have taken this position B, just touching the ground, just before touching the ground. So the position B means the ball is just before touching the ground. Okay, so just before touching the ground, the ball. Okay, so this is the height h. Okay, so when the ball was about to drop, that means when I was releasing the ball, at that time the velocity was 0 at this position. When I just dropping the ball, that means at that time the velocity is 0. Okay, so as it is moving downward, it is gaining some velocity due to acceleration due to gravity. Okay, so as the ball is moving downward, the ball will gain its velocity. Okay, so just before touching the ground, let the velocity be v. I just take it. That means let the velocity be v. Now I am taking. So at this free fall, this is the example of free fall. I am taking the example of free fall. Now why is free fall? Free fall means in this experiment I will consider that there is no air around us, or I can say that the air friction. Now see, if the ball is moving downward, we have air around us. So if anything is falling inside the air, that means the air friction will be there. That means outside the ball, the air friction will be there. So this air friction may lose the energy. So I neglect that air friction. Okay. So this is a free fall. Free fall means free from any other forces except the gravitation force. So here when the ball is moving downward, only the gravitation force is acting on the ball, and we neglect all the other forces. That means air drag, that is air friction, okay, viscous force. So everything I can say you will learn in the higher class. That means in class 11 you will learn the viscous force and everything. Okay, so I neglect all these things. Okay, because this viscous force or air drag may lose the energy. That means that force will take away the energy of this ball. Okay, so I just dropping the ball is under the gravity. Okay, so this is the example of free fall. Now what is the thing is that we will show that total energy is conserved. That means, now see, this ball has the mechanical energy, the ball is falling due to its mechanical energy. That means when the ball was at height h, what was the potential energy? Potential energy was mgh. We all know the formula of potential energy. That means when the ball was at position A, at that point the potential energy is mgh, and since the velocity is zero, kinetic energy we know that half mv square. That means v is 0, means half mv square is also 0. Okay, so at this position, at the position A, and at the position B, consider at the position A, the height is h, that means from the base, that means from the ground, the ball is at height h. That means the potential energy stored there inside the ball is mgh. And to kinetic energy, that means at this position A, there is no velocity of the ball. That means at this position the kinetic energy is 0. Now the ball is moving downward. Just before touching the ground, the ball will have a velocity v. Okay, but say, now tell me, what will be the potential energy at the point B? What will be the potential energy at the point B? Now see, while touching the ground, there is no height. Height is 0. That means mg into 0 is ultimately 0. Okay, so just before touching the ground, potential energy is 0. That means at the point B, the potential energy is 0. And what will be the kinetic energy? Kinetic energy will be half mv square. Clear? So half mv square. Now let's take any other point. Let's say this is the point C, and while at this point is situated, this is x distance, so this will be h minus x distance. Let's say the ball, so while falling down, I am taking another position at the position C. At the position C, the ball, let's say the position of the position of the C from A is x. So this distance is x and this distance is h minus x. Let this distance is x, so this distance will be, total is h, this distance is x, so this distance will be h minus x. Clear? So at this position, at the position C, potential energy will be how much? Now from potential energy means from how much height from the ground the ball is there. So this position means this height we have to consider. This height we have to consider. So mg h minus x, kinetic energy will be, let's say at this position, let's say at the position C, the velocity of the ball be v1. Let's say it is v1, then the kinetic energy will be half m v1 square. I think it is clear. Okay, so the ball is falling under the gravity. So this is one position, this is the second position, that is mid while position, and this is the last position just before touching the ground. Okay, so the three position I have taken, and I have calculated the three. So I have calculated the energy, that is kinetic energy and potential energy, and the three different positions. Okay, now I will show that at every position the total energy, that is total mechanical energy. What is mechanical energy? Mechanical energy, it is potential energy plus kinetic energy. Okay, so we know mechanical energy means potential energy plus kinetic energy. Now I will show that during this motion, I will show that the total energy of the body, that is total kinetic energy of the body, will remain constant. Okay, so let's see. So here at the position A, at position A, potential energy equal to mgh, kinetic energy equal to kinetic energy is 0. So mechanical energy equal to potential energy plus kinetic energy equal to mgh plus 0. That means mgh. So this is mechanical energy, means the total energy. So this is the total energy of the body at the position A. Okay. So at the position A, the total energy is mgh. Okay. Now let's calculate at position B. So at position B, the potential energy is 0. Just now I have said that means the potential energy at the position B is 0. Kinetic energy equal to half in v square. This thing I have taken. Now from third equation of motion. What is third equation of motion? Third equation of motion states that final velocity square equal to initial velocity square plus 2gs. What is gs? Gs is the acceleration due to gravity. Sorry, actually the thing is that it is written as as. Actually it is written as as, but in this case the body is under gravity. That means if the body is falling under gravity, the acceleration, in place of acceleration, we know that we have to put acceleration due to gravity. So if the ball is falling under gravity, then the acceleration will be done due to gravity. Acceleration will be there due to gravity. So in place of A, we have to put G. G means acceleration due to gravity. That means 9.8. Or for the easiness of the betterment of solving the problem, we can take G is equals to 10 meter per second square. Okay. So now here you will see what was the initial velocity. Initial velocity was 0. So when I just dropping the ball, so initially the velocity was 0. So when I was just dropping the ball, initially the velocity was 0. So here you have to put u is equals to 0 square. 2 in place of acceleration you have to put g. And what is s? S is the displacement. So the total thing is that how much displacement it covered. So from this height to this, how much displacement it is covering? H distance is covering. So from A to B, how much distance is covering? That is H distance is covering. Okay. So this is 2gh and this is the final velocity v. So v equal to root over 2, or you can say, we can just take it as v square only. We can take it as v square only, so v square we get that 2gh. Okay, so I just put this value in this equation. What I will get? I will get kinetic energy is equals to half m into 2gh. This is the thing I will get. Okay, so this 2 and this 2 will get cancelled out and it will come as mgh. So here also the kinetic energy come to as mgh. So total energy is equals to potential energy plus kinetic energy. Potential energy is 0, kinetic energy is mgh. So total energy equal to mgh. So here also at the position B, the total energy come to as mgh. So at position A, the total energy was mgh. At position B, the total energy again come to as mgh. I think the derivation, that is the mathematical, very easy derivation. Very easy derivation. If you go through once or twice, that means you have to practice it. Okay. So if you go through once or twice, do division once or twice, you can easily get it. Okay. So at position B also, the total energy is mgh. Now I will show at position C also the total energy is mgh. Okay. So let's do. Okay. So now at point C, at point C, at the position C, what will happen? Potential energy is equals to mgh minus x. What is kinetic energy? It is half v1 square. Okay. Again, we will use third equation of motion. Again, we will use third equation of motion. That means when the ball is falling under gravity, that means initial, what does third equation of motion says? V square equal to u square plus 2as. Again, in this case, the initial velocity is 0. That means this is the initial, at every time the initial velocity is this. So just dropping the ball, when I was dropping the ball, initially the velocity is 0, then it is 0 square plus 2gh, not 8 actually, sorry, it should be s, displacement. So the ball has traversed how many displacement, how much displacement it traversed? That is from A to C, the distance is x I have considered. So I have to replace s with x. This is v square. So v square I can write 2gx. Okay. So that means v1. That means final velocity is v1. That means at this position the velocity is v1. So I have to put v1 here. Okay. So this is the general equation. That means velocity equal to final velocity equal to initial final velocity square equal to initial velocity square plus 2as. Okay. So in this case, the initial velocity is 0 and final velocity is v1. I have just put this. Initial velocity is 0, final velocity is v1. Okay. So after solving this, we end up with this equation. Okay. Now I just put this value here. So what I will get? Half m into 2gx. So this 2 and this 2 can get cancelled out. mgx. So kinetic energy is equals to mgx and potential energy is equals to mgh minus x. So total energy equal to potential energy plus kinetic energy. So total energy, the potential energy means mgh minus x plus kinetic energy is mgx. That means mgh h minus mgx plus mgx. This will get cancelled out. mgh. See, at the position C, total energy comes out as mgh. Hence, I can say in this experiment, that means in case of free fall, the energy is conserved. Okay, so the question will be asked that show that in free falling object, any free falling object, in case of any free falling object, show that the total energy is conserved. Then you have to do the whole derivation. You have to do the whole derivation, you have to do this diagram, and you have to end up with these things. That means total, you have to show that at point A also the total energy is mgh, at point B also total energy mgh, at point C also total energy is mgh. Understand? So this is the case. Now the same thing will happen if I throw any object. Okay, so let's do, if I throw any object, then what will happen? So what will happen if I throw any object? This is the base. So I am throwing an object. That means initially I am giving some velocity. Let's say this velocity be v, and the position is a position. Okay, and the ball attain the height h. This distance is h. So this is position B. Okay. So here, when the ball is moving upward, and the ball, it has, let's say it has mass m. So as the ball is moving upward, there is the force due to gravity which will act downward, mg. So obviously, if the ball initially it has a velocity v, as it is moving upward, there is a dragging force. That means the force due to gravity will try to pull the ball downward. So the body will move and it will get slowed down. That means acceleration will be in this direction, but the motion will be in this direction, upward motion. So ultimately, the body will get stopped. You can do it by yourself also. If you throw the ball upward, ultimately the ball will go, and for some second it will be stopped there, and then it will again return down. So as the ball is moving upward, since the force due to gravity will act themselves pull downward, so the ball will decrease its velocity. The ball will decrease its velocity, and ultimately at this position, the velocity will become 0. Now, as the velocity becomes 0, I can write kinetic energy is also equals to 0. And what about the potential energy? Here, the ball, it attained the height h. That is, from the ground level, it attained the height h. So, potential energy will be mgh. Simple thing. Here, just when I was throwing the ball, it has a velocity v, so kinetic energy will be half m v square, and potential energy, since there is no height from the ground, that means height is equals to 0. That means mg into 0, that means 0. So here the potential energy is 0. Now I will take any point. Let's say this point, this is C, and this point, it has a distance x. So this distance will be h minus x. Same thing. If this distance is x, then this distance will be h minus x. Then we will get this distance, that is h minus x. Okay. So here the velocity will be v1, then kinetic energy will be half m v1 square, and potential energy will be mg x. X is the distance from the ground level. So x is the distance, that means this x is actually the distance from the ground level. From the ground level, this distance is x. Then this distance will be h minus x. Then this distance. Okay. So this is from the ground level. Okay. So mgx. Till now, I think it is clear. Now, at point A, kinetic energy is equals to half m v square. Potential energy is 0. Now, again we will apply the third equation of motion. Now, you will see, as the body is moving upward, but the force is acting downward. That means the ball is moving against the gravity. The ball is moving against the gravity, and we know that if any object is moving against the force, that means the retardation will take place. It means ultimately the body will stop. Just like in case of friction, if you stop paddling the bicycle, ultimately the bicycle will stop. Why? Because the motion is against the friction force. So here also, if the ball is moving upward, the weight will bring the ball, try to bring the ball downward. That means weight is acting downward, but the ball is moving upward. So the ball, the motion is occurring against the gravity. That means that retardation will take place. Now we know that retardation is minus sign. So we have to use minus here. We all know this. That means if the retardation is taking place, then the third equation of motion equal to v equal to u minus 2as. Now, we know that final velocity is 0. Ultimately, when the ball will move upward, ultimately the final velocity will be 0. So this will be 0 square equal to u, that is initial velocity is v. That is v minus 2 acceleration due to gravity, and s is h. Okay. So this will come as v square equal to 2gh. Put the value in this equation. That means kinetic energy equal to half m into 2gh. Again it is coming as mgh. So total energy is equals to potential energy plus kinetic energy equal to 0 plus mgh. Ultimately it is coming as mgh. So at the position A, the total energy is mgh at the position A. Now at the position B, at the point B, kinetic energy is 0. Potential energy is mgh. So total energy equal to kinetic energy plus potential energy. That means 0 plus mgh equal to mgh. Here also, at point B also, the total energy is mgh. Okay. Now, at point C, what will happen? Now, at point C, what will happen? So this is for upward motion. This is for upward motion. Okay. Okay. So at point C, at point C, what will happen at point C? Potential energy is actually what? mgx. Kinetic energy is what? m half L v1 square. Okay. Again we will use third equation of motion. Okay. Now see here, initial velocity is v and final velocity is v1. So v1 square equal to, wait, in this case we will do, yes, in this case we will do, yes, this one minus 2gh. Okay. Now what was the v1, sorry, what was the value of v? Just you can rewind the video, you will get that the v, we got v square equal to 2gh, and sorry, this x is equals to x. That means this distance. What is the displacement? X. That means x. So v1 square equal to 2gh minus 2gx. That means v1 square equal to 2gh minus x. I just put this value here. What will happen? It will come as half m into 2gh minus x. This will get cancelled out. M g h minus x. So now total energy is equals to m, yes, m g x plus m g h minus x. This is potential energy, this is kinetic energy. So again we will do m g x plus m g h minus m g x. This will get cancelled out, m g h. So at point C also, that means at point C the total energy is again coming as m g h. So here also total energy equal to m g h. Here also the total energy equal to m g h. Here also the total energy equal to m g h. Hence we can say that during upward motion also the energy is conserved. Okay. Now you will see if I so at point C you will get potential energy equal to m g x and kinetic energy equal to m g h minus x. If I say x equal to h by 2, that means at the midpoint. At the midpoint of the, that means if it is h by 2 and it is also h by 2, that means at the midpoint of the motion, you will see if I put here, then potential energy equal to m g h by 2. That means half of the total energy, potential energy. In kinetic energy, mg h minus h by 2. That means here also mg h by 2. So you will see at the midpoint of the motion, you will see that the kinetic energy is half of the total energy, potential energy is half of the total energy, and kinetic energy is equals to potential energy. Kinetic energy is equals to potential energy. So at the half of the motion, it is kinetic energy equal to potential energy. Kinetic energy is equals to potential energy. During the free fall also you will see. During that free fall, we get that during the free fall, we also get that during free fall, we get that potential energy was mg h minus x and kinetic energy was mg x. Here also if you put x equals to h by 2, then also we will get this equals to mg h by 2, same calculation. This also equals to mg h by 2, same calculation. During the free fall also we will get at the midpoint of the motion kinetic energy is equals to potential energy. Okay. So till now I think it is clear. Very easy calculation. Do it once or twice. If you don't understand for the first time, rewind the video, repeat the video, and you will understand. Just copy it. That means with the video only, you will copy it in your copy and try to make it understand. It is very easy. It is nothing so much complexity is there. So I think it will be easier for you to understand. Okay. So during free fall, at this position, at the position A, the potential energy mgh, kinetic energy equals to 0 at initial position. At any point C, potential energy is mg h minus x and kinetic energy equals to, or I can say at the midpoint. C is the midpoint. This is the midpoint. At the midpoint, potential energy is equals to mg h by 2. Kinetic energy also equals to mg h by 2. Okay. So just before touching the ground, at the point P, kinetic energy equal to mg h, potential energy equals to 0. So in this case, initially the body possesses all potential energy. There is no kinetic energy. Now when it was just touching the ground, just before touching the ground, all the energy converted to kinetic energy and the potential energy becomes 0. You see, potential energy converted to kinetic energy. Simple thing. Okay. Now, during upward motion also the same thing, that is when it was throwing, that means at the initial level it was all kinetic energy. When it is moving upward, the all kinetic energy is converted to potential energy. Now we will draw energy versus height graph. We will draw energy versus height graph. Now see, if I want want to plot potential energy versus height graph, so initially, that means when the height was 0, at this point means when the height is 0, at the origin means when the height is 0, that means at this position all the energy was kinetic energy. This was the kinetic energy maximum. All the energy is the kinetic energy. As it is moving upward, the kinetic energy decreases and ultimately it becomes 0. So at the height equal to 0, that means at the origin, that means at just before touching the ground, that means h equals to 0, all the energy is kinetic energy. As it is, suppose it is, it will be better if I take the example of yes, no, it is okay. That means at the origin, means at height equal to 0, that means at this position all the energy is kinetic energy. As if you move upward, that means you will see the kinetic energy become half at this position, and ultimately the kinetic energy becomes 0. So ultimately the kinetic energy is decreasing and it is equal to 0. And if you think at this position, what is the potential energy? At h equal to 0 means at this position the potential energy is 0. So here the potential energy is minimum. As you move upward, you will see that from 0 it gains mgh by 2, and ultimately it becomes mgh. So this is the potential energy and this is the kinetic energy. So this is actually mgh and this is actually total energy is mgh and this is actually mgh by 2, and here actually it is h by 2. At h by 2, kinetic energy is also mgh by 2, potential energy is also mgh by 2. That's why, since the both energy is equal, that means it is intersecting at this point. That means at h by 2, the two curve will intersect. Okay, so at h equals to 0, that means at this position the maximum energy is the kinetic energy. So as you move upward, you will see the kinetic energy is decreasing, and at h equals to 0, the potential energy is minimum, that means 0. As you move upward, the potential energy is increasing, and at the height h, the potential energy is maximum. Okay. Now at h by 2, both the energy will be mgh by 2. Okay. So both the energy is half of the total energy. Okay. So this is the graph of the upward and downward motion. Okay, so this is how we can show that total energy is conserved. Okay. Now we can take a simple example of simple pendulum. We will take a simple example of simple pendulum. What is simple pendulum? So pendulum means, let's say this is the string, and if I connect a bob, that means if this is the string and I connect a bob of mass m. Okay, so this is the simple pendulum. Now this is position B. Let's say, let's say the position B A. So this is the initial position. Okay. Now from the position A, I take the bob here. That means I take the bob here. here. That means at point B. Then I release the bomb. That means I take the bomb here and I just released it. So what I have done is a simple pendulum. It was at rest, and I have taken the bomb here at this position B and just released. What will happen? It will move. It will move, and ultimately it will go at this position. Yes, it will move, and this is the point C. So, simple pendulum from the point A, I take the bomb at the position B and release. Then it will again go and come here, and it will oscillate. So, at this position B, see, if I take the bomb and release here, at this position the velocity is 0. Here also, at this position also the velocity is 0. Okay. So if the velocity is 0, then kinetic energy is also equals to 0. Here also, the kinetic energy is also equals to 0, I can say. Now, if I consider this as a base, then from the base, if it is at height h, and if this is also at height h, this distance are height h, then what will happen? The kinetic energy, potential energy is equals to mgh. Here also the potential energy is mgh. Now, since at the position A there is no height, so I can say here is no height. That means the potential energy is equals to 0. So kinetic energy is equals to a half m v square. Let's say v is the velocity at the point A. So if you see the simple pendulum at this two extreme position, the velocity of the simple pendulum becomes 0. Okay, so it will go again, it comes here and again come in this direction. Again it will go at this position, the velocity becomes 0, and it will again come to this position. So you will see that here the potential energy becomes maximum and kinetic energy becomes 0. As it is moving here the potential energy becomes 0 but kinetic energy becomes maximum. If it is go at this position, the potential energy becomes maximum, kinetic energy becomes 0. So this way the energy transition will take place, energy transformation will take place from potential energy to kinetic energy to potential energy. This way the total energy, this way the energy will transform. Okay, now let's see. I will show that here also the total energy will remain constant. Okay, so here let's say the bomb is coming, so at this position the velocity is 0 and at this position the velocity is v. So B is the initial position. Let's say B is the initial position of the bomb and A is the final, let's say final position. Okay, so at B initial velocity is 0. At A, the final velocity is v. Final velocity is v. Now we will again use the third equation of motion, that is v equal to u square plus 2as. Now here again the body it has the weight mgh. So mg, here also it is mg. So here acceleration is again acceleration due to gravity. That means u is actually 0 plus 2gh, v square equals to 2gh. So v square is equals to 2gh. So at point A, kinetic energy is equals to half m v square equal to half m into 2gh mgh, and potential energy here actually it is 0, I can say, since there is no height. So I can say at point A, total energy equal to potential energy plus kinetic energy, 0 plus mgh. At point B, total energy equal to potential plus kinetic. Potential energy is mgh, kinetic energy is 0, here also mgh. At point C, total energy equal to potential plus kinetic, so mgh plus 0, that means mgh. So in case of simple pendulum also, at every position of the simple pendulum, the total energy is conserved, that means mgh. Only the transformation of energy is taking place from potential to kinetic, the kinetic from potential, again from potential to kinetic, then again kinetic to potential. So this energy transition is taking place. Understand? So this is the last unit of the second chapter. Do revision. Do all here actually the derivations are there. Do all the derivations. Practice once or twice and do revision. Actually, you have to. The only way to make it clear is the revision. Okay. So do it. Thank you.